Okay, so here we are. This is section 6.1, which is exponential functions. Okay, so exponential functions. So what are we doing in this section? Here is an exponential function. I'm going to make that y, same thing, y f of x equals 2 to the x minus 3 power. So what is an exponential function first off? It means, an exponential function means x is in the power zone. X is up in the power zone. That's what it means to be an exponential function. So for example, if I have x squared, this is not exponential. Even though it has exponents, exponential, it's not exponential because only x is not in power. The 2 is in the power zone, right? The x is not in the power zone. There is a power, 2's the power. So it's not just anything that has powers or exponents. An exponent means a power, right? Exponential functions particularly mean not just that there are powers, but that x itself got into the power zone. So that's an exponential function. So x squared, for example, or x cubed, none of those are exponential. Even though they have exponents, they have powers, x did not climb into the power zone. Only when x is in the power zone is it called an exponential function. Okay, so this is an exponential function because x is in power. It's in the power zone. So that's an exponential function. So that's what this section 6.1 is all about. So first off, let's begin by just looking at a graph. What is an exponential function? What does the graph look like? Let's make a little XY chart. And let's just begin by graphing this thing and see what we can find. Now, I'll explain why later, but for now, I'm just going to plug in 3 for x. Let's begin by plugging in 4x, the same number that's up there next to x. It just works out nicely. You'll see as we go. So y will equal 2 to the 3 minus 3. So I plugged in 3 for x. And so that's 2 to the 0. And what is anything to the 0 power? Do you remember? Anything to the 0 power is 1. That's an important fact to remember. Anything to the 0 power is 1. So there we go. So that's the point, over 3 up 1. There we go. There's the dot. Over 3 up 1. That's one of the dots on the exponential function because it makes it true. Now, let's just add 1. Let's go up by 1. So let's go to 4. So we started with the number that's next to x. You could really plug in any number, right? Any number you want, but this is just what's going to be easy. What are we going to get now? 2 to the 4 minus 3. I'm plugging in 4 for x. That's 2 to the 1. 2 to the 1 power is just 2. So that's over 4 up 2. That's just right here. Over 4 up 2. That's all you need is 2 points, but let's just do another one for fun. What if we plug in 5? What are we going to get? Y equals 2 to the 5 minus 3, which is 2 to the 2, which is 4. So that's 5, 4. So over 5 up 4 right there. Over 5 up 4. And let's do another one. Just want to see where this thing is going. 6. If we plug in 6, what are we going to get? Y equals 2 to the 6 minus 3. Just keep plugging in to wherever x is. That's 2 to the 3. That's 2 times 2 is 4 times 2 is 8. Over 6 up, way up here at 8. Over 6 up 8. Look at that. Do you see what the function's doing as we go to the right? It's going up, 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 really, really fast. If we plugged in something like 7, it would go crazy. 2 to the 7 minus 3. That's 2 to the 4th. 2 times 2 is 4 times 2 is 8 times 2 is 16. Over 7, up 16. It's like way, way up there. It's rocketed way up there already. Now, what does it do if you go further to the left? Well, I won't bother with a bunch of it. We'll get into it more later. But basically what it'll do is it'll come down like this. So there's what the exponential function looks like. So, and when you graph it using the graph maker, really you only need 2 points. You just click on 2 points. These two are fine, and it'll do the rest of the graph for you automatically. But I just wanted to give you a nice look at an exponential function. They basically rocket up. When we talk about something growing exponentially, like the coronavirus growing exponentially, that means it's rocketing up to the right. It's the way diseases usually spread. More and more people get it, which make more and more people get it, and it kind of explodes. That's exponential growth, rocket growth. As you go up to the right, it explodes upward. Okay, so number 2, same kind of thing. So we're going to, we have y equals minus, and it's 1/6 to the x minus 3. Okay, we're going to make an xy chart. We want to get a couple of points to graph. Let's start with 3 again, because whatever number they put next to x, that's just easy. So what does y equal? It's going to be negative, so y will equal negative 1/6 to the 3 minus 3. That's negative 1/6 to the 0. Anything to the 0 power is 1. So this whole part becomes 1. The negative stays in the front, that negative that was already there. So it's negative 1 over 3 down 1. There's the first point. Let's do another one. See what happened there? I plugged in 3, and this is 1/6 to the 0. Anything to the 0 power is 1, and the negative in the front makes it negative 1. Now let's plug in 4. And this becomes minus 1/6 to the 4 minus 3, which is 1. So that's just minus 1/6. So over 4 down a 1/6. That's kind of difficult number to do. Over 4, how do you do down a 6? I don't think, we can estimate it, right here. Like that, over 4 down a 6. But you're not going to be able to do it with the graphing, tools, because how are you going to do a minus a 6? Let's try going the other way instead. Instead of going up by 1, let's go down to 2. See what we get. So y is minus a 6th to the 2 minus 3 power, which is minus a 6th to the negative 1. Now, here's a lot of the trick of this exponential function. There's a few facts you need to remember. Here they are. Here's some facts about exponents. Fact number 1, any number to the 0 power is 1. Second fact, anytime you have a fraction, like a over b, to a negative number, it flips the fraction, becomes b over a to the positive number. It flips the fraction and then becomes positive. Negative powers flip a fraction. So this minus will stay in the front, this fraction will flip upside down, and then the power will become positive. See what happened there? The negative part of the power doesn't make the number in front negative, it flips the fraction. Negative power flips the fraction and then becomes positive. So what does this equal? Negative 6 over 1 is just 6. 6 to the 1 is just 6. This is negative 6, meaning over 2 down 6 right down here is the other dot. And yeah, so that's what we get. And so really that's enough information. The graph is going to do this. It'll make the rest of it for you. It'll basically do this. Like that. That's what the rest of the exponential graph will do. So that negative inside has made the exponential flip down instead of up. So you just have to graph 2 points, this point and that point. Just find 2 points that you can put on the graph, and it'll make the rest of the exponential for you. There we go. So exponential functions rocket up or down. If they have a negative in front, they rocket down. And on the other side, they flatten out. See how it flattens on this side and rockets down on that side? The last one flattened on this side and rocketed up on that side. So they always rocket up or down on one side, flatten on the other side. It's actually got a horizontal asymptote there. We'll talk about that more in the next section. All right, so that's kind of the introduction about what exponential functions generally do. They rocket up on one side, flatten out on the other. Now, we'll do a whole section on graphing in the next section, 6.2. But let's do some kind of word problems involving exponentials now. So, a population numbers 10,000 organisms initially and grows by 19.9% each year. Suppose that P represents the population and T represents the number of years of growth. Here's the model. So we're saying P equals A times B to the T power. So notice it's exponential because the variable is up there in the power zone, exponent zone, exponential function. So this is the general look of an exponential equation. You have something in the front, call it A, times some other thing, B for base, to the T power. And so, here's the deal. That B is actually can be broken down to be 1 plus R to the T. So, the R is the rate. Let me explain. The R right there is the rate of growth, per year or whatever the time unit is. In this case, year, each year. So what that means is, so this B breaks down, we separate the B into two parts, 1 plus R, where R is the rate of growth per year. So this is going to be, and what's the A? Let me explain. The A, so we've explained the R. The A there, A equals the starting amount, the initial amount or starting amount. So the A is going to be the starting amount. What did it start out at? 10,000 organisms initially. So that's 10,000, parenthesis, 1 plus R. R is the rate of growth per year. What's it say? It grows by 19.9% per year. So 19.9%, that's the R, that's the rate of growth. But we got to change that to a decimal. We don't want any percentages. So let's make that a decimal. Remember how to turn that into decimal? It just goes back two places. 0.199. 0.199. And the power is the T. So simplifying this is 10,000, 1.199, because the 1 added to the 0.99, the 1 here added to the 0.199 makes 1.199 to the T. There we go, and that's exactly what they have here as the answer we got. So that's how it works. Let's try that same thing on number 2. Again, we say, okay, P is A, B to the T, but we break that down. The B can be rewritten as 1 plus R to the T, where, again, the A equals the starting or initial amount, and the R is the rate of growth per year or per whatever, and this one. So what do we have here? We have the A coming first. That's the 14,000 organisms initially times 1 plus R. What's the rate of growth? It says right here 2.6% each year. Change that to a decimal, 0.026. I move that back 1 2 places becomes 0.026 to the t. So simplify that. P equals 14,001.026 to the t. That's what they get. Oh, wait a minute. I better read more carefully. That isn't what they got. This is minus here. Why is this a minus? I didn't read the word decreases. See, the last one was grows by, so that was a positive. This one decreases, so subtract. Use your calculator. Take 1 minus 0.026, and you're going to get 0.974 to the t. There we go. So if it's increasing, if it's growing, then the r is positive, and if it's decreasing, if it's decreases, then the r equals negative 0.026. So increase positive, decrease negative. No big surprise there. I just have to pay better attention. All right, so there's questions 3 and 4. Not too bad. Now number 5. The fox population in a certain region has an annual growth rate of 7% per year. It is estimated that the population in the year 2000 was 10,400. So find a function that models the population t years after 2000. So in other words, t is 0 in the year 2000. So this is almost always how these science problems work. They pick some point in time to be the starting point. So in this case, the year 2000. So then all of time is measured from that starting point, in this case from the year 2000. So we'll use the same formula as before. P equals A, 1 plus r to the t. Remember, the A is the amount that it started with, the initial amount. Does it say? Oh, yeah. It was 10,400 in the year 2000. Is that the starting year? Yeah. That's they said, everything's going to be measured after the year 2000. So that's the starting year. So yes. 10,400 is our A. 1 plus growth, so it's plus. The R is 7% positive because it's growth. Change that to a decimal, 0.07, right? Because decimals here goes back 1 2 places. 0.07 to the t. So that's 10,400, 1.07 to the t. That's the answer they got for the first part. And then part B, now use this function to estimate the fox population in the year 2008. So in the year 2008, that means t equals 8. That's 8 years after the year 2000. Remember, the starting time was 0 in the year 2000. So we're starting from 2000. 2008 is time 8 years after the start. So just plug in t equals 8 to that formula. Here we go. Population will be 10,400 times 1.07 to the 8. See, I just plugged in 8 right there for time. Okay, then use your calculator on that one. So you're going to take 10,400 times 1.07 to the power, like the up arrow, or on your calculator it might be y to the x or some other button like that for power, to the 8th power equals. Hit those buttons and you'll get 17,869. That would be the fox. As the fox population continues to grow at, 7% per year, then by the year 2008, there's going to be 17,869 foxes, starting from 10,400 back in the year 2000. It'll grow that fast. All right, let's see. Let's see if we can do the same thing on number 6. Let me section this one off for number 5. So for number 6, a vehicle is purchased for $22,400. It depreciates at a rate of 8%. That's 8% per year. We're assuming 8% per year. That's what they mean by constant rate. 8% per year. So we have the same formula, A, no, not A, P equals the amount times 1 plus R to the T. And what is the A? What's the amount it started at? $22,400 times 1. Now it's depreciating. So the R, in this case, the R is negative 8%, which is negative 0.08. So minus 0.08 to the T. See that? Because it's depreciating. It's going down in value. So it's decreasing, not increasing. So the rate is negative. The R is negative 8%, negative 0.08. So then the P is 22,400. 1 minus 0.08 is 0.92 to the T. So there's our formula. Now they want us to use that formula. Here's the question. Determine the approximate value of the vehicle 13 years after purchase. So now we're going to take that and we're going to plug in T is 13 for 13 years after purchase. So grab that 13 and plug it in. So we get 22,400 times 0.92 to the 13th power. So on the calculator, you'll type in 22,400 times 0.92 to the power, up arrow or X to the Y or whatever power button on your calculator, 13 equals, and you get the answer $7,577. So the vehicle is dropped in value from 22,400 down to only 7,577 after 13 years because it's dropping at 8% per year. There we go. All right, that's number 6. Number 7, very, very similar kind of question. Car was valued at $44,000 in the year 1993. The value depreciated to $12,000 by the year 2003. Okay, so let's use the normal formula we've been using, where the P is A times 1 plus R to the T. So the car was valued $44,000 in the year 1993. We're going to have to make that the starting. Remember, in all these science problems, this is a financial, economic science problem. There's always a starting time. So this one's going to be 1993 is when it started. So at that time, the amount, remember that's what A is, the amount at the start. So the A is the 44,000. The R is the rate of growth or decay. In this case, it's depreciating. It's going down. It went down to 12,000 by the year 2003. What does that mean? Well, what that means is the P, the principal value, was 12,000 when T was the year 2003. Now, what's the year 2003? Well, 2003 minus 1993, because that's our starting time, 1993, that's 10 years later, isn't it? So when T is 10, in other words, the value became $12,000. The car had dropped to have a principal value of $12,000 10 years later, right? You know, it started in 93 and then 10 years later to the year 2003. So that means if I plug in 10 for T and plug in 12,000 for P, it's got to make the equation true, right? So I can plug in, so P is 12,000 when T is 10. So plug in 10 for T. This one's a little more tricky here. Plug in 10 for T and 12,000 for P, because they've got to make the equation true. This is an equation connecting principal value to time based on a rate. So now I plugged in $12,000 value at t equals 10 years later. So now I've got to solve. What do they want me to find here? They want me to find r, right? They're asking for r over here. Well, that's a pretty tricky equation to solve for. How do we solve for r? R said, I want to be alone, get rid of this 44,000, get rid of this 10 power, and get rid of this 1 so that I can be alone. So one of the fanciest things we've solved so far. So the first thing to do is just to divide off that 44,000 because it's multiplying. So opposite of multiplying is divide. So we divide that 44,000. On the other side, we get 0.272727. It goes, on and on. I'll just leave it right there. Six digits is good enough. Well, we're still in the middle of the problem, so we want to use as many digits as possible. 1 plus r to the 10th power. Now we're trying to get r alone. Next we got to get rid of that 10th power. How do we get rid of a 10th power? Well, you know what we do to get rid of that 10th power? Let me rewrite it so we can see it really clearly here. 0.272727. To get rid of that 10th power, you raise both sides to the 1/10th power. And it cancels out. Do you see that? Because a 1/10th power is the opposite. Or you could 10th root. It's the same thing. A 10th root is a 1/10th power. Same thing. It doesn't matter. So these guys will cancel. They're gone. So we just have 1 plus r. You don't need the parentheses anymore. They're not raised to a power. So on your calculator, here's what we do on your calculator. 0.2727. Well, let's just keep it as it is for now. And we'll finish it. We're about done. To the 1/10th power. Last step to get r alone, subtract 1 from both sides. Boom. So we've got it. R is finally alone. It's 0.272727 to the 1/10th power minus 1. So type that into your calculator. So you got to go 0.272727. You got to put parentheses around it. To the power, and then you got to put parentheses around the 1 divided by 10. Then you got to go minus 1 and hit equals. And this is the power button, or right here. It might be x to the y depending on what kind of calculator you're using. So you got to do that to the 1/10th power, and then subtract 1. And I'm getting r came out negative 0.1218, which is indeed the answer they got right here. So this is negative 0.1218. It's negative because the rate is decreasing, right? The car is decreasing in value. It's dropping in value. All right, now they want me to change that to a percentage. You know how to change a decimal to a percentage. It just moves it 2 places. So it'd be negative 12.18. It just moves the decimal 2 places. Boom, boom. When you put on the percentage there. Now the final part, part C here, they say assume that the car value continues to drop by the same percentage. What will be the value in the year 2006? 2006. So now I've got this formula. Let me write it over here where I have a little room. I've got the formula P equals A. What was the A? 44,000. And then 1 minus it's 0.1218 to the t power, right? Because the r came out to be negative 0.1218. You're supposed to go plus r. Plus a negative is, same thing. So that's P equals 44,000. 1 plus negative 0.1218 is 0.8782 to the t. Now we're going to plug. Now they want us to plug in for the year 2006. 2006. How many years after the start is that? When did we start again? The year 1993, right? So subtract 1993. That's what? 13 years. 13 years later. So plug that 13 right in there for t. So this is 44,000 times 0.8782 to the 13th power. So put that on your calculator now. 44,000 times, you got to type it in. 44,000 times, you don't need that comma. Let me try that again. So you got to type in 44,000 times parenthesis 0.8782 parenthesis to the power 13 equals. So type that in. And I'm getting, let me see here. Okay, and when I do that, here's the answer I get. I'm getting $81.31. But notice here, go back here, they said round to the nearest $50. So in $50 increments, if you go up, it would be $81.50. If you go down, it's $8,100. Those are going by 50s, right? $8,100, $8,150, $8,200, etc. Going by 50s. So rounding to the nearest 50, which 50 amount is it closest to? 81.31 is closer to 81.50, isn't it? Than it is to 8,100. So we're going to say the answer is 81.50. That's how they got that answer. It rounds closer to 81.50. There we go. Okay, so that was a pretty challenging problem. Let's go on then with number 8. So again, that last part we rounded 81.31 to the nearest 50. 81.50, it's closer to that than it is to 8,100. All right, so number 8, I think I'm going to get a fresh screen where we have some room here. So for number 8, it says we've got an exponential function, f of x is a times b to the x, and they're saying it has the points, it passes through the points 0, 7 and 356. And then it wants me to use that information to find A. Oops, I meant to spell and there and blew it. A and B. I was thinking about the B already. A and B. All right, so how do we do that? Well, remember, this is y equals, so this is x, y, x, y. Whenever they give us points, right, it's x then y. So if I take the function y equals a times b to the x, and I just plug in the x right there, the y right there, what do I get? 7 equals a times b to the 0. Now, remember, what is anything to the 0 power? Any number to the 0 power is 1. So this is 1. This is a times 1. So that means a is 7, because a times 1 is just a. So a is 7. So now we know a, the value of a is 7. Okay, now for the second point, the 356, let's write again y equals a times b to the x. We know the a, it's 7. It's 7 everywhere now, so now we know what a is. Now all we have left is to find b. Let's plug in the information. This is x, so this 3 is going to plug in right there, and this 56 is y, is going to plug in right there. So 56 is 7 times b to the third power. So we can solve that equation for b, can't we? Divide by 7 on both sides. B is saying, I want to be alone. Divide by 7 on both sides. And we get b to the third power. 56 divided by 7 is 8. And now, how do we turn that into just normal b? Because we're trying to get, b alone. So what's the opposite of a third power? Well, you could do a third root, or you could do a 1/3 power. Same thing. A third root is a 1/3 power. These guys cancel out. B's alone. Let me make that back in the blue color there. B is alone. And what is 8 to the 1/3? Just take your calculator, go 8 to the power. Maybe your power button is x to the y or up arrow. Parenthesis, 1 divided by 3 equals 8 to the 1/3, and you'll get 2. B is 2. So we got A, we got B. All right, let's try number 9. It'll be about the same thing here. Do number 9 again. We've got y equals a times b to the x. I give them a 0. This is x, y. So plug in 0 for x and 12,000 for y. So 12,000 is a times b to the 0. So that means 12,000 is a. And what's b to the 0? What's anything to the 0? It's 1. It's a times 1. So an a times 1, that's just a. So a is 12,000. So we got our hands on a again. A is 12,000. Let's write the equation again now. Y equals a times b to the x. But now we know a. A is 12,000. B to the x. Okay, now again, let's plug in x. This is, x then y. And this is y right there. So we get 96 is 12,000 b to the third. How do we solve that for b, right? B said I want to be alone. So divide by the 12,000. Like that. Your calculator will tell you it is 0.008 equals, and these cancel, b to the third. Bring that down here. B to the third is 0.008. How do we get rid of that third power? You know how to get rid of that third power, right? 1/3 power, or third root. Same thing. A 1/3 power is a third root. Cancels this out. Do this on your calculator, and you will get 0.2 for b. You have to go 0.008 to the power 1 divided by 3. It equals, and your power button might be x to the y or up arrow, and you'll get 0.2. So we got A, 12,000. We got B, 0.2. And there's the same answers that they got on those. Now, last problem, number 10. Let's get a fresh screen here. Got a little bit of room. It's going to be a little bit of a longer one. So number 10, they're giving us a couple points. -1 3/5 and 1/15. And they want us to find a formula. They're saying find a formula for an exponential function. And we know exponential functions are of the form y equals a times b to the x, right? So that's the kind of thing we're looking for, a times b to the x. Okay, so how are we going to do this? Well, this is an x and a y and x and y. Let's plug them in. This one's going to be a little bit harder because they're not giving us a 0. If you look back on number 8 here, they gave us a 0. That made it nice. On number 9, same thing. They gave us a 0. So those were easier. This one will be a little harder. Let's plug it in. So the x, the -1, goes right there. The 3/5 goes right there. I'm going to take that 3/5 and make it a decimal. if you take 3 divided by 5 in your calculator is 0.6. So a times b to the negative 1. A times b to the negative 1. All right, let's just leave that for a moment. Let's go over and do the other one. So in the other one, same formula, a times b to the x. I'm going to plug in the 1 for x and the 15 for y. So I get 15 is a times b to the 1. Okay. So now what we're going to do is going to be a little tricky. So we've got this and we got this. I'm going to solve for a here, and then I'm going to plug in a there. So I'm going to solve for a in the first equation and plug it into the second. Remember this method when you have two equations, this equation and this equation, you have two equations with two letters. What you do, we have two equations, they both have a and b. You solve for one letter in one equation, plug into the other. So, all right, so how am I going to do that? So let me come on down here. We have 0.6 equals a b to the minus 1. Well, you have to remember an important fact. Any number, let's just call it, x to the negative 1 is 1 over x. X to the negative 2 is 1 over x squared. X to the negative 3 is 1 over x cubed, etc. Negative powers flip to the denominator, then become positive. You need to know that truth about negative powers. They flip something to the denominator, then they become positive. They flip it. So this b to the minus 1, that's really a over b to the 1. Does that make sense? That b flips down, so it's a over b to the positive 1. It flips it down like that. It then becomes a positive power. So negative powers, I always say they're negative where they're at. They're unhappy. It's like somebody's unhappy at their job. They want to jump to the other side of the fraction, wants to jump down, and then it becomes positive happy. Okay, so what? Well, we're trying to solve for a. Remember what you do when you have a fraction on one side? You put a 1, cross multiply. Now that we have a fraction, you know how to handle this cross multiply. So we get 0.6 b to the 1, which is just b, is 1 times a. So that's 0.6b. 1 times a is just a. So we solved for a. Solved for a. We did. It's 0.6b. Now take that and plug it in for a right there. Right? And then this equation will become 15 equals, and what is a? 0.6b to the 1. Well, you can leave the 1 there. Times the other b to the 1. You're tracking with what happened there. Let me change the color. That might make it more obvious. This is our 0.6b to the 1 that was a. You see that? So the 15 still in the front, the b to the 1 still in the back, but right where a was, we now have 0.6b to the 1 because a is 0.6b to the 1. We solve for it in the other equation. So now we have 15 equals 0.6b to the 1 times b to the 1. Now what's b to the 1 times b to the 1? It's just b times b. It's b squared. Remember powers add? Like if you have b squared times b to the 3rd, that'd be b to the 5th. Remember those rules from powers? When you multiply letters, the powers add. Okay, so now what am I trying to do here? I'm trying to solve for b. How can you solve for b? Divide by the 0.6 on both sides. B squared equals, divide that in your calculator, 15 divided by 0.6. It'll come out 25. Almost there. Root it. B's 5. So we got our hands on b. So now all we need is a, and we'll have this thing. Let me get rid of some of these rules right here. And now we've just got to get a. So where are we at? Well, you grab either one. I'll just grab, say, this one again. Bring it over here. And now it said 15 is equal to a times b to the 1. A times b, in other words. A times b to the 1. Right? So, and now we know what b is. So 15 equals a times b. b is 5. 5 to the 1, or just 5. How do you solve that equation for a? 5 to the 1 is just 5. Just divide both sides by 5, right? Boom. We got a. A is 3. So we've got a, we got b, we got our formula. So our formula is y equals a times b to the x power. We now know a is 3 times b, which is 5, to the x power, right? All along it was y equals a times b to the x. That was from the beginning, right? Y equals a times b to the x. Now we found a to be 3, found b to be 5, plug them in, 3 times 5 to the x. There we go.